Bismillahirrahmanirrahim. Assalamu alaikum students. Welcome to the Power Electronics lecture series at ComSets Abbottabad. In this lecture, we shall discuss the overall course review and the topics we have studied so far in this course. So this is the last lecture of this Power Electronics lecture series. So in the beginning, we have divided the course into 5 parts. In the first part, we have studied the basics of the power electronics and the power electronic devices, their structure, operation and switching characteristics. In the second part, we have learned the operation and analysis of the rectifier circuits. In the third part, we have learned the operation and analysis of the DC choppers. In the fourth part, we have learned the operation and analysis of single and three phase inverter circuits. And in the fourth part, we have learned the AC to AC power conversion with the AC voltage regulators and cycloconverters circuits. And also this course has a lab work, and all the labs are performed by using the MATLAB software. In the introductory part, we have learned the basics of the power electronics converters and systems, and we have learned how we can use the power electronic circuit to match the voltage and current requirements to the load. We have also learned what are the power semiconductor devices and how we can classify them and how we can use them for various applications. We can also classify them in terms of power and capability and switching speed. Like MOSFETs can be used for low power and high frequency applications, and thyristors can be used for high power and low frequency. We have also learned how we can choose various power electronic semiconductor devices for different applications. So looking at the characteristics of each device, we can choose the particular device for different application. We have also learned what are the wide bandgap power semiconductor devices and their switching characteristics. These are the newcomers in the market of power semiconductor devices. So these devices has the capability of handling large voltage and currents along with the fast switching characteristics. So after the part 1, where we have studied the power semiconductor devices, their structure, operation and switching characteristics, in the second part we have studied various power electronic circuits. We started the power electronic circuits from the uncontrolled rectifier, then we have studied the controlled rectifier, then we see the operation analysis of the DC choppers, and then we investigate the single and three phase inverters, their operation analysis, and at the end we ended the course on the AC to AC power conversion and focusing on the AC voltage regulators and the cycloconverters. So in the rectifier sections, we have studied both controlled and uncontrolled rectifiers. We have used half bridge and full bridge circuits for single and three phase supply. So the first circuit from the rectifier sections we have studied was the half wave rectifier with resistive load. We have learned its operation, and we have derived the performance parameters for the half wave rectifier using both resistive and inductive load. We have also analyzed the full wave center tap rectifier with our load, and also develop its performance means derived its performance parameters. Similarly, we have also analyzed the full wave bridge rectifier with R load. We have learned its complete operation by using resistive and inductive load. So after the uncontrolled sections, we have studied the controlled rectifiers, starting from the half wave controlled rectifier with resistive load. We learned its complete operation and derived the expressions for the average output voltages and currents and RMS quantities of both the voltages and current. Likewise, we have studied the half-wave rectifier, controlled rectifier with our load, and we learned its complete operation and its analysis. And we have also studied the single-phase full-wave controlled rectifier with our load and learned its complete. Similarly, for three-phase circuit, we started our analysis from the uncontrolled rectifier with resistive load. We have learned its complete topology and its operation and analysis, and we derived the performance parameter for the three-phase full-wave uncontrolled rectifiers, and also for the controlled rectifiers. And at the end, we have learned the 12 pulse rectifiers, how it works and how we can use it for different applications. So the next section was the DC-DC converters, chopper circuits. So we have learned the complete operation analysis of the DC-DC converters, where we classified these converters into non-isolated converters and isolated converters. For the non-isolated converters, we have learned complete operation analysis of the buck, boost and buck boost converters. And for isolated converters, we have learned the flyback and forward converters, and we have learned the complete operation and analysis of these isolated converters. The isolated converters are those topologies of the DC-DC converters where the transformer is used as the isolation device. So, so for controlling of the output of the DC-DC converters, we have learned two control techniques. One was the pulse frequency modulation, and the other was the pulse width modulation. The fourth part of the power electronics course was the inverter circuits, means DC to AC, where we have learned different topologies, how we can convert a DC into AC signal. For both single and three-phase power supplies, we use the half-bridge and full-bridge topologies, and we also learned how we can classify the inverter circuits based on the source signal. So one was the voltage source inverter and other was the current source inverter. So as we discussed earlier, for single phase inverters, we have used the half bridge and full bridge topology to analyze the inverter circuits. We have used the bridge topology for the analysis of three-phase inverter circuits. The fifth part of power electronic circuit was the AC-AC conversion, where we have learned how we can achieve a variable voltage from a fixed AC source or a different frequency from a fixed AC source. So to achieving a variable voltage at the output of a converter, we have learned that there are two methods. One is called on-off or integral cycle control, and the other is called phase control. So for both the methods, we have learned how these techniques are working and how we can get the variable voltage at the output of a converter. Moreover, we have also learned that what are the different types of AC phase controller. So we can classify them into single phase and three phase, and also in unidirectional or half wave AC controller or bidirectional or full wave AC controller. So you can see that the different types of AC phase controller shown here. We have learned the complete operation and analysis of all these types of AC phase controller. So in the next phase, we have learned that how we can achieve a variable frequency from a fixed AC source. So we learned that there is a circuit named cycloconverter is used to achieve a variable frequency from a fixed AC source. We have learned that there are two types of cycloconverter. One is called step down cycloconverter and other is called step up cycloconverter. We have also learned that there are two different methods to achieve a variable frequency and a voltage at the output of a converter. One is called DC link converter method and other is called direct method. So for the direct method, we have analyzed both step up and step down cycloconverter by using midpoint and a bridge type topology, that how we can achieve a frequency a signal at the output of a converter having frequency greater or lower than the source frequency. And also we have learned that how we can achieve a single phase output signal having frequency lower than the source frequency from a three-phase supply. We have learned the complete operation and analysis of three-phase to single-phase cycloconverter. So this was the complete course we have studied at ComSets, Ahmedabad. We are hoping that you people have find this course very informative and interesting. Thank you very much for your patience and best wishes for your final exam.